Good afternoon, everyone. Thanks for staying, and thanks for inviting me. This is my first ISMB. I'm a computer scientist by training, so hang out at NeurIPS and at Clear and KDD a lot more. First time I'm coming here, and I love it. I can't wait to be back. So thanks for inviting me this great event. Today we're going to talk about lots of solutions to improve biomedical data reuse, so many that might not have time to go through all of them, so please give me a 5-minute warning at the end. And let's start with what is SAGE? SAGE is a nonprofit based in the United States and in Europe, and we have the mission of bringing open and collaborative practices to the biomedical field. We do open science with protected data, I like to say. So we try to thread carefully between privacy of patients and openness that's needed for reproducibility. And we do so building tools like Synapse, that is a generalist repository, not part of the GREAT initiative yet. I hope soon we can contribute there. That hosts more than 3.5 petabytes of omics data across 20,000 projects. We also build portals around some of these data sets that are around the specific theme. So for example, we have the AD knowledge portal, the elite portal for exceptional longevity, the cancer complexity portal. Those are funded by NIH and NCI respectively. And our chief data officer, Sushil, will be talking about some of those later on today, I think at the Bosch track. So I'm going to make my presentation around this beautiful infographics from our friends at Elixir that represent the data, biomedical data lifecycle. And making the case that this is the world we would like to live in, where we plan for data, we collect it, we process it, we analyze it, we preserve it, we share it, we reuse it, and that informs the next cycle. But the reality is a little bit more like this. A lot of silos here and there in labs and institutions and countries. Everyone is doing that cycle quite effectively, but then what gets reused out of that cycle and into informing other cycles is limited, sometimes delayed, sometimes polished for only positive results. And we all know all these things, right? And we all know why that is, right? I could have a 15-minute or a 50-minute presentation about the reasons why we got there. Some people say that in biomedical data, we have open data in appearance only. Folks have said that linking 5 national data sets have been challenging, laborious, and at times demoralizing or seemingly hopeless. We've been taught by folks in the high energy physics that open itself is not enough. You actually need to do a lot more things for reuse to happen. And fundamentally, all these points go about making the case that Christine Borgman at UCLA is making, that we have to think about distances between data creators or data generators and data reusers. And those distances are across many dimensions: language, temporality, curation. And we have to intentionally think about each of those distances and try to remove them or shrink them. And that's what we're trying to do as SAGE. And I will make the case today that AI, and not the amazing stuff that I've seen this morning with quantum and things that really maybe I could understand 15 years ago in my computer science PhD, but definitely not anymore. Not that kind of stuff. Off the shelf, low-hanging fruit can do a lot for biomedical data reuse. So I claim, those antennas don't show in my preview, by the way. The robots have antennas now. That's interesting. I claim that each of those steps in the data reuse cycle, possibly minus collection, where we don't have robots yet, but soon we will, and preservation, that is more of a technology, storage problem. Any other of those steps can be helped by some sort of AI. And I'll go through each of them as time allows. So let's start from table stakes. Data deposition and management plans. We've heard earlier that a lot of funders have request their their grantees to prepare a data management and sharing plan that basically asks you what kind of data you think of collecting, how you're planning on sharing it, what kind of repository to use, what kind of governance controls. And these things can get they can get pretty long to fill. Like there are forms and they ask a lot of details beforehand, and you're writing a grant and you have to submit it before midnight and it's 11:55. So we thought about, well, why don't I just take the grant narrative, put into an LLM and have it help us do a first draft of that form. And first draft is really here is keyword. We don't want these things go, out wire and fill up forms for us and submit data management plan for us, but help us make that hour-long filling form tedious exercise into a 5-minute one. So this is from one of our foundations funder, the Children Tumor Foundation, but for the NIH data management plan would work just the same. Again, table stakes, like everyone should have some form of that in their website if they're supporting some data contribution. And yeah, that's what it looks like. You put in a chatbot, your grant narrative, and it gets you a 80% or 90% filled form that then you can have just to adjust before submitting. Now, another table stakes, knowledge extraction from unstructured data. We've heard many talks of folks using LLM to get dirty data into analysis-ready data. This is just another iteration, another instance of that. And the example I have at hand is from one of our researchers in rare disease that have noticed that really would love to have natural history for some of the mouse models used in this particular case, neurofibromatosis, but this natural history is scattered across hundreds of paper and described in natural language in different ways. So LLM come to the rescue with a bit of prompt engineering. That's actually quite a bit of prompt engineering. And now there are workflows that help you to do prompt engineering. The SPY is one of those. This prompt on the left-hand side goes through papers, extract observation, and then you can show them in a nice timeline, as you can see on the right-hand side. Again, is it perfect? No. Is it better than reading 400 papers yourself? Yes. Okay, now this one is a really exciting one. It's one that Sage has not, this has not worked from us. We're not really working on co-scientists yet, but I think it's going to be an enabler of many things in biomedical science, especially data reuse. So what are co-scientists? If you've been on the news for the last 3 or 4 months, you've probably seen press release from Stanford, Biomi, Future House, Robin and Finch, and the Google co-scientists. Those are end-to-end, well, they're meant to be end-to-end assistant for a biomedical researchers to start with a very high-level question and then help the researchers through data collection, data discovery, analysis on this data, and then iterate on results. The way they look like is, like on this right-hand side, this is one of the co-scientists that has been built as part of the ARPA HBDF program, of which we are part. It's kind of a notebook plus a chatbot interface. So instead of having to figure out how GG2 works and what are the craziness of a NumPy's array, you just really focus on what kind of things you would like to ask of the data and then check the results. Now, one thing that I think is really important to notice in this co-scientist on the right-hand side is the left-hand side columns. The list of data sources that are connected by this co-scientist that allows a user ask the very high-level question that I'm asking at the very top. I'm looking for doing research on longevity. What data set should I be looking at? So this is solving both data discovery and data analysis at the same time. And I think this is going to be an incredible catalyzer of data reuse because you don't have to go out and look for data sets yourself anymore. You have them integrated in your analysis pipeline. You can query it directly. Now, big question there is like, how do you access controlled access data like this? And there's work being done on that, and we're working on that to Sage, but at least the fully open data sets are all there. Next step, data curation. This is the bugbear of all folks that are trying to deposit some data for open reuse. Why? Well, because you're collecting data, you're doing your analysis, you're writing your paper, And now it comes the time where you have to put it on Synapse, and it's 5 years after you collected the data, the grant has run out, some of your students have left, and you just have to do it, and you have to harmonize to this weird ontology that someone else is telling me to do so, that I haven't chosen myself, meaning it's a task that does not incentivize people at all, and it's really a pain. And I think AI can make this pain a little less hard. And so with funding from ARPA-H BDF program, we're building a curator assistant, a co-pilot if you want, that once you have your data set and you want to deposit it, for example, on Synapse, we'll start making suggestions on how to annotate based on your historical annotation of data sets that are similar to yours, and you basically have to spending more time reviewing and confirming rather than figuring out from scratch every time why DOB needs to be spelled out as date of birth. Okay, this is having a lot of success again because this has been a pain point we've heard for more than a decade at Sage. And bonus point, if you really want to make your data reused, also by folks like me in the AI community, then make it AI ready. Then on top of your metadata that you usually have in the bio world, try to use a croissant. In this particular case is the metadata we are using, format that describes how that data can be used for machine learning. So the idea then is as a modeler, with one click, you can load this data set in your favorite AI framework like PyTorch or TensorFlow or Keras, whatever you're using. Train and test splits are already set out for you. Hyperparameters are already configured for you. You have to spend a lot less time to get to training as you would otherwise. And this has been developed in collaboration with a lot of folks in the tech industry, led by a consortium called ML Commons. All right, synthetic data. This is a great, this is a thing that I care about a lot. I would give a talk just about that, but I probably have only 30 seconds to talk about it. I think synthetic data is synthetic, so it's not real. So we're not going to write Nature papers on it. This is to be clear. But it could still be a great gateway to the real data. It could be something that is used while the real data is not available, while the access control is being reviewed or given, or to decide whether you have even to embark in the access control request because maybe you figure out from the synthetic replica that's not the data set that you wanted because it doesn't have the number of patients you thought it would. So synthetic data is something we're working a lot at Sage and in collaboration with UW Tacoma. We are working on this specific grant, NSF grant, on the NAIR architecture, which if you take one point out of this talk is something you should be looking at. NAIR stands for National AI Research Resources. I've heard from many people yesterday after John Jumper's talk about the need for more GPUs. Like everybody is starving for GPUs. It's true in computer science, and now it's becoming true in our domains as well. NAIR is a place that can help with that. Right, like this is a network of national labs plus industry in-kind availability, and it's become really helpful if you have to do heavy-duty machine learning generation, like we need to do for this synthetic data project that aims at generating a replica of a rare disease patient with privacy-preserving guarantees. So, data discovery, and I'm off to wrap it up. Can AI help with data discovery? And the answer is yes. I have a past in tech, building search engines. I think that searching for data is much harder than searching for web pages, right? Query matching, it just doesn't work. For data, there's a much larger semantic gap that you have to cover to understand from what you don't even know how to articulate, whether you know that data set will answer or disprove your question. And so we found that a conversational interface that helps you refine your thinking, proposing data sets and then going back and say, is it really the one you were thinking about? So a reasoning model aided by tools that can query the whole Synapse data bank is something that we are piloting as a use to search for data. So if you go to synapse.org, you log in. It's only available to login users because these queries, as you know, are quite expensive. You log in, then you can chat with Synapse. Of the 20,000, 3.5 petabytes of omic data sets that are there, you can start figuring out which one you might be able to use for your own research. Okay. The last point is less about AI tools and more about what do we need to do with those. Well, we clearly need to make them as open as possible so other people can build on it and use it. But not only for that, we also need to make them as open as possible because we need to understand whether they work or they don't. Is my knowledge extraction tool better than yours? Well, I might argue that it is the case in my Nature paper. You might argue that it is the case in your Nature paper. But unless we compare them on a single open benchmark, we're never going to know. So benchmarks and challenges, which are basically benchmark plus a prize and a competition, is something that we've been running at Sage for more than a decade. We've been doing that for models in AI that are using for health. And I think it will be even more important to do so for all the tooling that we're building as biomedical researchers assisted by AI now. And if you go to the Dream Challenge track, which is the track I'm splitting time with today, they'll be talking a lot about how do you evaluate that. Finally, I want to leave you with a thought. I cannot convince you that open source code and open as possible data in the biomedical field is a good thing. There's no research that's looking at that counterfactual if we had more of that. But someone has done that economical counterfactual research for open source code because it's been around for a bit longer. And it turns out that the cost of writing that code is 4.something billion. Economists call it the supply side cost. But the cost that it avoids, the step that's built on top of it, is 8.8 trillion. That's the demand side cost, economists call it. So the value, the ROI is immense. And I claim that this is actually a floor to what we will have in health if we have more open and more reused data. Obviously, none of this is my work. I'm the PowerPoint guy. This is the team that's actually doing the work at Sage. And these are the funders that are making it possible. Please reach out to me. And our Chief Data Officer, Sushil, and our CTO, Alberto, are also around for the rest of the week. Thank you.
Excellent. Thank you, Luca. Questions? We have time for maybe one or two. Anyone else has a question?
Thank you, Nick, for letting me take the opportunity to ask the only question. So I have a question about the data accuracy, AI-assisted data curation, because this morning we have the keynote speak. He worked with 200 biocurators. The most important value for data curated by human is data accuracy. And so we all know AI has hallucinations. So how do you resolve the data extracted from literature? They are correct. Second, even it is correctly extracted from literature, but they have errors. Same thing mentioned by the keynote speaker mentioned today. 50% of the data literature.
I'm sorry, I didn't get the second point. Can you repeat the second point?
Even you extracted the data from literature correctly, but the literature itself could have errors. So as a human biocurator, they have their knowledge, they have their own judgment. They can correct the errors even in the literature.
Yes.
How could AI do that?
So yeah, these are great points, and I really loved the talk this morning of Amos. I was there clapping, and I kind of recorded this presentation by just taking a picture of every single slides because they were so good, and agree with every point that he made. That the fact that we feel like curating is too slow, and even I myself as a computer scientist coming into this field, I'm like, well, why are we spending so much time doing this manual work? Is it needed? The answer is yes, it is needed. But can it be sped up? I think it's the nuanced question that we need to answer. And at least in our research, and this is work we're doing again with the BDF ARPA-H program, it will be formally evaluated by an external team that is not us on metrics on whether the curation is good enough. And so the short answer to you is we will see if it actually works or it doesn't. It might not. And that's how science works. If I were to give a first principle, gut feeling driven answer is that it's a big behavioral incentive to be able to start, like there is a dopamine rush kind of argument to the fact that if you have to start from scratch on uploading a data set that you have to completely annotate by hand with no help at all, it just doesn't happen. Like we have backlogs accumulating for years. But if you have a system that it allows it to be piecemeal and it allows you to verify and change things over time on your own pace, then you're doing it. So there's at least that. There's the difference between doing and not doing from a behavioral psychology perspective. And then the correctness, I think, needs to be assessed in a scientific way.
All right, thanks again. Actually, did we have one more question behind you, Feng Lao? Can you give that to Seppi? Yeah.
Appreciate it. Actually, thank you so much for the talk. I almost took every single slide you showed. I took a picture of it. I appreciate it. You mentioned synapses about the discovering data. I was wondering if your institution or you're aware of a similar bot for discovering tools, the software tools. I understand it, when it comes to software tools, we're not talking necessarily off the shelf, downloadable, something we could get and use. Could be also methods of an algorithm that exists in unstructured data that we talked earlier today. Are you aware of it? Do you know if there is some efforts?
Yeah. So thanks for the question. First of all, like we talk about data, but like tools are as important. And if in our portals, if you go to any of those, the NF, I think is a good example. We have a data section, a tool section, a paper section. So we consider tools as first tier citizen. Right now in the chat system, tools are not part of the answer the LLM looks at, but the researcher that's working on NF, the rare disease researcher, his name is Robert Alloway, actually has extended that for tools in the NF community only, so which is a small rare disease community, and is seeing good results. And I think it will be something that we definitely want to consider and extend. I'm happy to connect about that.
And thanks so much again, Luca. Really appreciate it.
Thank you all.
One more round of applause. Thanks, Luca.